What if the epic history of Afghanistan, of empires rising and falling, of conquerors and traders, was not just written in stone and scripture, but is still alive today, encoded within the DNA of its people? Could the genetic signature of a Greek soldier, an ancient farmer, or a Mongol horseman still be traced in a modern Afghan family? We journey into the past not through archaeology, but through the surprising science of human genetics. The foundational layer of the Afghan genetic tapestry was woven not by warriors on horseback but by the patient hands of the first farmers, whose arrival in the mountainous corridors and fertile valleys of what is now Afghanistan marked a profound transformation of the human story in the region. This Neolithic revolution, beginning roughly 9,000 years ago, represents the deepest significant stratum of ancestry for many modern Afghans, a genetic bedrock upon which all subsequent migrations and admixtures would build. Scientific analysis of both Y-chromosomal DNA, which traces paternal lineage, and mitochondrial DNA (mtDNA), which follows the maternal line, reveals compelling evidence of this ancient agricultural expansion. The dominant signatures from this era are haplogroups such as J2 and G on the Y chromosome, which are widely recognized as markers carried by the early agriculturalists who fanned out from the Fertile Crescent in the Near East. Their slow, generational migration was not a conquest but a demographic and cultural wave, carrying with them the revolutionary technologies of plant cultivation and animal husbandry. They introduced domesticated wheat and barley, along with goats and sheep, which allowed for the establishment of permanent settlements, a departure from the nomadic lifestyle of the Paleolithic hunter-gatherers who had previously inhabited the land. Archaeological sites across the region, such as Mundigak in Kandahar province and the early levels of settlements in the foothills of the Hindu Kush, provide tangible proof of this transition, with discoveries of grinding stones, primitive sickles, and the bones of domesticated animals. The genetic data suggests a complex interaction between these incoming farmers and the indigenous populations. Rather than a complete replacement, the evidence points towards a model of admixture, where the pre-existing hunter-gatherer gene pool was gradually absorbed by the more numerous and demographically successful farming communities. This fusion is critical to understanding the unique genetic landscape of Afghanistan. It created a localized version of the Neolithic genetic signature, one that was already a blend of Near Eastern farmer and Central Asian hunter-gatherer ancestries. This ancient melding process explains why certain mtDNA haplogroups with deep roots in Central Asia are found alongside the classic Near Eastern farmer lineages. The environment of the Hindu Kush itself played a crucial role, with its isolated valleys acting as incubators for distinct genetic profiles to develop even within this broader Neolithic framework. As communities became sedentary, they adapted to specific microclimates, and over thousands of years, founder effects and genetic drift would have further sculpted their DNA. The legacy of these first farmers is not merely a faint echo in the distant past. It is a living component of the Afghan people. The prevalence of haplogroup J2, for instance, particularly in Pashtun and Turkic populations, is a direct link to this era. This haplogroup is often associated with the highlands of Western Asia, and is thought to have been instrumental in the spread of agriculture through mountainous terrains. Its intricate subclades tell an even more detailed story of subsequent migrations and differentiations, but its root presence speaks to this fundamental agricultural beginning. Similarly, haplogroup G, while less common, is a strong indicator of this same demographic movement. The enduring impact of this period cannot be overstated, as it established the agricultural foundation that would make the region a future crossroads of civilizations. The surplus food production enabled population growth, the formation of complex societies, and the development of trade networks that would later blossom into the Silk Road. In essence, the genetic contribution of the Neolithic era was not just about the introduction of new DNA. It was about the introduction of a new way of life that irrevocably shaped the destiny and the very biological makeup of the people who would come to call this rugged, beautiful land their home. This deep-seated ancestral layer provides a crucial context for all later genetic inputs, acting as the canvas upon which the vibrant and complex portrait of Afghan DNA was painted over the subsequent millennia. It is a testament to the resilience and adaptability of these early peoples, whose genetic legacy perseveres in the faces and the DNA of Afghans today, a silent story of the dawn of civilization in the heart of Asia. A significant and sophisticated stream of genetic inheritance flowed into the lands of ancient Afghanistan from the south, originating in the sprawling, highly organized urban centers of the Indus Valley Civilization, IVC. Flourishing from approximately 3300 to 1300 BCE, this Bronze Age civilization, contemporaneous with ancient Egypt and Mesopotamia, was one of the most extensive on Earth, with its influence reaching far beyond its core territory in the plains of the Indus River. For the populations inhabiting the southern and eastern regions of modern Afghanistan, the IVC was not a distant, foreign power but a major trading partner, a cultural influence, and a source of significant gene flow. Genetic studies have identified a distinct ancestral component, often termed Ancient Ancestral South Indian, AASI, related or Indus periphery, which is a key element in the DNA of many Afghans, particularly among Pashtun groups and other communities bordering the Indian subcontinent. This genetic signature is a direct legacy of the peoples who built the great cities of Harappa and Mohenjo-Daro. Archaeological evidence provides a clear picture of the intimate connections between these regions. Sites like Mundagak in Kandahar and Shorchigai in Badakhshan province are prime examples of this interaction. Shorchigai, remarkably, is considered to have been an IVC trading colony, established far from the civilization's heartland primarily to control the lucrative trade in lapis lazuli, a deep blue semi-precious stone mined almost exclusively in the nearby mountains of Badakhshan. The presence of a full-fledged IVC settlement so deep within Central Asia implies not just casual trade but a sustained presence of Indus Valley peoples, including merchants, miners, artisans, and administrators, over many centuries. This long-term cohabitation and interaction inevitably led to intermarriage and the mixing of populations. The genetic markers left by the IVC people are complex. They represent a unique blend of ancestry that had itself formed over millennia, combining lineages related to early Iranian farmers with those of the indigenous hunter-gatherers of South Asia. When these individuals moved into and interacted with the communities in ancient Afghanistan, they introduced this specific genetic cocktail into the local gene pool, which was itself a composite of Neolithic farmer and Central Asian hunter-gatherer ancestries. The result was a new layer of admixture, a gradual blending that created a genetic continuum stretching from the Indus Valley into the foothills of the Hindu Kush. The analysis of Y-DNA haplogroups such as L and H, and certain subclades of R2, which are particularly common in the Indian subcontinent and are found in significant frequencies in parts of Afghanistan, are thought to be associated with the demographic landscape of the IVC. The L haplogroup, in particular, has a strong correlation with the geographic extent of the Indus Valley Civilization and its periphery. Its distribution among modern Afghan populations often mirrors the ancient trade routes and areas of known IVC influence, providing a molecular map of this prehistoric connection. The decline of the Indus Valley civilization around 1900 BCE did not erase its genetic footprint. As its cities were abandoned, possibly due to climate change that altered river patterns and disrupted agriculture, its people dispersed. It is highly probable that some of these population movements were directed northward and westward, back along the established trade routes into Afghanistan. This diaspora would have further reinforced the IVC genetic signal in the region, as entire communities sought refuge and new opportunities in the more stable, mountainous environments. This legacy is more than just a series of haplogroups. It represents a cultural and technological exchange that shaped the development of Bronze Age society in Afghanistan. The IVC brought with it advanced knowledge of urban planning, standardized weights and measures, sophisticated craft technologies, and distinctive artistic styles, all of which would have influenced the local cultures. The genetic inheritance from the Indus Valley is therefore a reminder that for much of its early history, Afghanistan was not solely a crossroads between East and West, but also a vital bridge to the great civilizations of the South, a connection that is indelibly stamped into the DNA of its people. A transformative genetic and cultural shift occurred in ancient Afghanistan during the Late Bronze Age and Early Iron Age, driven by the arrival of nomadic pastoralists from the vast Eurasian steppe. This series of migrations, popularly associated with the Aryans or Indo-Iranians, introduced a powerful new genetic component and laid the linguistic foundations for most of the languages spoken in the region today. Beginning around 2000 BCE, these tribes, originating from the Sintashta and Andronovo cultures in the steppes of modern-day Russia and Kazakhstan, began a southward expansion. Their success was fueled by a potent combination of advanced military technology, including the horse-drawn chariot, and a mobile pastoralist economy based on herding cattle, sheep, and horses. As they moved into the territories of Central Asia and onto the Iranian plateau, they brought with them a distinct genetic signature, most prominently the Y-chromosome haplogroup R1a, specifically its Z93 subclade. This genetic marker is so strongly associated with this migration that it is often referred to as the Indo-Iranian marker. Its distribution across Eurasia forms a clear trail of this ancient expansion, from Eastern Europe through Central Asia, and deep into Iran, Afghanistan, and northern India. In Afghanistan, R1AZ93 is found at its highest global frequencies, particularly among Pashtun and Tajik populations, making it a dominant feature of the country's paternal genetic landscape. This high concentration suggests that the region was not merely a passive corridor for these migrating tribes but a major area of settlement and demographic impact. The arrival of these steppe peoples was not a single, unified invasion but a complex process of infiltration, settlement, and assimilation that unfolded over several centuries. They encountered and mixed with the pre-existing populations, the descendants of the Neolithic farmers and the communities influenced by the Indus Valley civilization. This admixture process was pivotal in forging the ethnogenesis of the modern Indo-Iranian peoples of the region. The steppe migrants' DNA blended with the established gene pools, creating a new synthesis. Genetically, this event is visible as the introduction of a significant proportion of steppe pastoralist ancestry, a component characterized by its own unique mix of Eastern European hunter-gatherer and Caucasus hunter-gatherer lineages. The linguistic impact of this migration was equally profound. The steppe people spoke early forms of Indo-Iranian languages, which belonged to the larger Indo-European language family. As they became the dominant demographic and political force in the region, their languages spread, eventually differentiating into the Iranian branch, giving rise to Pashto, Dari, and other languages, and the Indo-Aryan branch, which spread further into the Indian subcontinent. The sacred texts of Zoroastrianism, the Avesta, and Hinduism, the Vedas, contain linguistic and cultural clues that point to this shared origin and migration period, with many scholars believing that parts of this history unfolded in the lands of ancient Afghanistan, which the Avesta refers to as Aryan of Asia, or the homeland of the Aryans. The cultural package brought by these pastoralists included more than just chariots and language. They introduced new religious ideas, centered on a pantheon of sky gods, the ritual use of fire, and the veneration of the horse, elements that would deeply influence the subsequent religious development in both Iran and India. They also had a distinct social structure, organized into tribes and warrior elites. This societal model likely played a role in their ability to establish dominance over the more settled, agricultural societies they encountered. The genetic legacy of the steppe migration is a cornerstone of Afghan identity, particularly for the country's two largest ethnic groups. It connects them not to the urban civilizations of the South or the farmers of the Near East, but to a vast, interconnected world of nomadic horsemen who roamed the Eurasian landmass. This R1A signature is a testament to a period of dramatic change, a time when new peoples, a new language family, and a new genetic profile swept across the Hindu Kush, fundamentally reshaping the demographic and cultural landscape in ways that are still clearly visible in the DNA of the Afghan people today. It represents one of the most significant and defining chapters in the country's complex genetic story. In the 4th century BCE, the geopolitical and genetic landscape of Central Asia was irrevocably altered by the arrival of a European army from the distant shores of the Aegean Sea. The conquest of the Persian Achaemenid Empire by Alexander I of Macedon was not merely a change of rulership, but a significant demographic event that introduced a new, albeit minor, stream of Mediterranean DNA into the Afghan gene pool. While the overall genetic impact of the Greeks was not as pervasive as that of the earlier Neolithic or steppe migrations, it represented a distinct and historically documented infusion of European ancestry, the legacy of which can still be detected through modern genetic analysis. Alexander's army, though led by Macedonians and Greeks, was a cosmopolitan force that grew as it marched east, incorporating soldiers from across his expanding empire. After defeating Darius III, he pushed further into the eastern satrapies of Bactria and Sogdiana, which correspond to modern-day Afghanistan and its northern neighbors. He spent a significant amount of time in this region, from 330 to 327 BCE, founding numerous cities, many named Alexandria, such as Alexandria Erekosiram, modern Kandahar, and Alexandria on the Oxus, likely Ai Khanum. These cities were not just military garrisons. They were intended to be permanent centers of Hellenistic culture, administration, and commerce. To populate them, Alexander settled thousands of his veteran soldiers, men who were unwilling or unable to make the long journey back to Greece. Furthermore, Alexander actively encouraged a policy of fusion between his people and the local populations. He himself married Roxana, the daughter of a Bactrian nobleman, and he famously organized a mass wedding at Susa, where he and 90 of his top officers took Persian and Bactrian wives, ordering some 10,000 of his soldiers to do the same. This policy, aimed at creating a new, blended Greco-Persian ruling class, facilitated direct gene flow between the European newcomers and the local Indo-Iranian inhabitants. The genetic markers associated with this historical event are subtle. Researchers look for specific Y-chromosome haplogroups that are common in Greece and the Balkans but relatively rare in Central Asia. These include certain subclades of E1b1b, J2a, and R1b. The presence of these Hellenic lineages, even at low frequencies, in modern Afghan populations, particularly in areas corresponding to the ancient region of Bactria, provides a molecular echo of Alexander's conquests. Y-Chromosome, a site in northern Afghanistan, offers breathtaking archaeological evidence of this Hellenistic presence. Excavations have revealed a complete Greek city, with a gymnasium, a theater capable of seating 6,000 spectators, temples built in the Corinthian style, and administrative buildings. Greek inscriptions and statues further attest to a vibrant Hellenic community that thrived for nearly 2 centuries after Alexander's death, first under the Seleucid Empire and then under the independent Greco-Bactrian kingdom. This kingdom, ruled by descendants of Alexander's generals, represented a unique cultural synthesis, as seen in its coinage, which featured Greek monarchs and deities alongside local motifs and inscriptions in Greek and local scripts. This extended period of Hellenistic rule, lasting until around 145 BCE, provided a long window for genetic exchange. The Greek soldiers and colonists and their descendants lived alongside the Bactrian people for generations, ensuring that their genetic contribution was not just a fleeting event but was integrated into the local population. While the Hellenistic infusion did not fundamentally alter the dominant genetic profile of the region, which remained overwhelmingly Central Asian and Indo-Iranian, it added a new layer of complexity to the Afghan genetic makeup. It serves as a classic example of elite dominance admixture, where a relatively small group of incoming conquerors and settlers leaves a disproportionate cultural legacy but a more modest, though still detectable, genetic one. The story of the Greek presence in Afghanistan is a testament to the region's historical role as a global crossroads, a place where East and West did not just meet but merged, creating new cultures, new kingdoms, and a new and more complex genetic identity for its people. The faint traces of Mediterranean DNA in an Afghan individual today are a direct link to this remarkable chapter of world history, a genetic memento from the soldiers who marched with Alexander to the very edge of the known world. Following the decline of the Greco-Bactrian kingdom, a new power rose from the east that would once again reshape the political and genetic landscape of Afghanistan, turning it into the heart of a vast and cosmopolitan empire. The Kushans, a confederation of nomadic tribes known as the Yuezhi in Chinese sources, swept into Bactria in the 2nd century BCE. Originally from the grasslands of northwestern China, they had been driven west by the Xiongnu, embarking on a long migration that eventually brought them to the fertile lands north of the Oxus River. By the 1st century CE, one of the 5 Yuezhi tribes, the Kushans, had asserted its dominance, unifying the confederation and expanding south across the Hindu Kush. At its zenith under Emperor Kanishk I in the 2nd century CE, the Kushan Empire stretched from the Aral Sea to northern India, with its core territories encompassing all of modern Afghanistan. This empire was a true melting pot, and its rise facilitated an unprecedented level of interaction and admixture between diverse populations. The genetic legacy of the Kushans is complex and multifaceted, reflecting their own nomadic origins and the diverse peoples they came to rule. Genetically, the original Yuezhi people likely carried haplogroups and ancestral components common among the peoples of the eastern Eurasian steppe and ancient southern Siberia. This includes Y-DNA haplogroups such as certain subclades of Q, C, and N, which are distinct from the R1A marker of the earlier Indo-Iranian steppe peoples. Their arrival and establishment as a new ruling elite introduced these East Asian and Siberian-related lineages into the Central Asian gene pool. However, the Kushan impact was not simply the addition of a new Eastern layer. As rulers of a vast, multicultural empire, they presided over a period of relative peace and stability known as the Pax Kushana. This stability secured and revitalized the trade routes that would become the Silk Road, transforming cities like Bagram, the Kushan summer capital, and Taxila into bustling hubs of international commerce. Merchants, pilgrims, artisans, and monks from across the known world, Romans from the west, Han Chinese from the east, Indians from the south, and Scythian nomads from the north, traveled and settled within the empire's borders. This immense network of connectivity fostered significant gene flow. The Kushan Empire became a genetic crossroads, a vortex where DNA from Europe, the Middle East, South Asia, and East Asia could mix. The Kushans themselves did not remain genetically isolated. Their elite rapidly intermarried with the local Greco-Bactrian and Indo-Iranian aristocracy they had supplanted, as well as with noble families from other parts of their empire. This process of admixture is reflected in their art and coinage. The famous Gandharan school of art, which flourished under Kushan patronage, blended Hellenistic artistic styles with Indian Buddhist themes, creating a unique cultural fusion that mirrored the genetic fusion happening at the population level. Kushan coins depicted a diverse pantheon of deities, including Greek, Roman, Zoroastrian, and Hindu gods, alongside images of the Buddha, demonstrating the ruler's syncretic approach to both culture and religion. The movement of religions, particularly Buddhism, along the Silk Road during the Kushan era also had a demographic dimension. Monks and pilgrims traveled from India to establish monasteries in Afghanistan, such as the great monastic complex at Bamiyan. These religious migrations, while perhaps not involving large numbers of people, contributed to the genetic diversity of the region over centuries. The Kushan period, therefore, represents a time of intense genetic mixing and layering. It reinforced the existing Indo-Iranian and Hellenistic strata while adding new elements from both East and West. The introduction of East Asian-related ancestry, though likely small in overall percentage, added a new dimension to the Afghan gene pool, particularly in the northern regions. More importantly, the Kushan Empire's role as the guardian of the Silk Road created a dynamic environment where continuous, low-level gene flow from distant lands became a constant feature. The genetic makeup of Afghans today carries the imprint of this era of globalization, a time when their homeland was the central hub connecting disparate worlds. The Kushan legacy is a reminder that Afghan DNA is not just a product of major migrations, but also of the constant, subtle currents of exchange that have flowed through the region for millennia. The collapse of the Kushan Empire in the 3rd century CE ushered in a new era of conflict and migration in Afghanistan, dominated by the rise of two powerful and competing forces: the Sasanian Empire from the west and the Hephthalites, or White Huns, from the northeast. Both groups left a distinct, albeit different, mark on the genetic landscape of the region, contributing new layers of Iranian and Central/East Asian ancestry to an already complex gene pool. The Sasanian Empire, emerging from Persia, saw itself as the successor to the Achaemenids and sought to reclaim the eastern territories that had been part of that earlier Persian Empire. For several centuries, they exerted control over western and southern Afghanistan, incorporating regions like Herat and Sistan into their domain. The Sasanian presence was primarily one of military and administrative control, establishing garrisons and installing governors. While this did not represent a mass migration of Persian people, it facilitated a steady, low-level gene flow from the Iranian plateau into Afghanistan over a long period. This would have reinforced the existing Iranian genetic signature, which was already present from the much earlier Indo-Iranian migrations, but it likely introduced specific paternal and maternal lineages more common in Western Iran. Y-DNA haplogroups such as certain subclades of J1 and G, which have a strong presence in the Zagros Mountains and Western Persia, may have seen their frequencies increase in Western Afghanistan during this period of Sasanian suzerainty. This genetic exchange was a two-way street. Sasanian armies frequently recruited soldiers from their eastern provinces, including Bactria, meaning that men from Afghanistan were also moving west and contributing to the gene pool of the wider Persian Empire. The Sasanian period was also marked by religious dynamics, with a state-sponsored Zoroastrianism competing with a well-established Buddhism and nascent Christian communities in the region, which could have influenced marriage patterns and, consequently, gene flow between different ethno-religious groups. A far more dramatic and demographically significant event was the arrival of the Hephtalites in the 5th century CE. A confederation of nomadic tribes of uncertain origin, the Hephtalites swept out of Central Asia and established a powerful empire centered in Bactria, Tokaristan, from which they launched devastating raids into Persia and India. The genetic identity of the Hephtalites is a subject of ongoing debate, but historical accounts and limited archaeological evidence suggest they were a mix of Central Asian peoples, likely with significant East Asian and Siberian ancestral components, possibly combined with an earlier Indo-Iranian, Scythian/Saka element. Their arrival represented a major new wave of migration from the northeast, distinct from the preceding Yuezhi/Kushan movement. The Hephtalites established a new ruling class and military elite across much of Afghanistan. Their dominance lasted for over a century, a sufficient period for significant genetic admixture with a local Bactrian, Kushan descendant, and Indo-Iranian populations. It is hypothesized that the Hephtalites are a key ancestral group for several modern populations in the region. Their genetic legacy is likely seen in the presence of specific East Asian-related Y-DNA haplogroups like C2 and Q, and mtDNA lineages, which overlay the existing genetic strata. This infusion of new Eastern ancestry would have been particularly strong in the northern and central parts of Afghanistan, the heartland of their empire. The Hephthalite period was one of great disruption but also fusion. They adopted many aspects of the local culture, including the Bactrian language for administrative purposes and elements of local religions, suggesting a degree of assimilation. This cultural blending was undoubtedly accompanied by genetic blending, as Hephthalite elites took local wives and their soldiers settled in the lands they had conquered. The subsequent downfall of the Hephthalite Empire at the hands of a coalition of Sasanians and the newly rising Turkic Khaganate did not erase their genetic contribution. The Hephthalite people were not annihilated. They were absorbed into the subsequent political and ethnic formations of the region. Thus, the Sasanian and Hephthalite periods together illustrate two different modes of genetic influence: the steady, assimilative pressure of a neighboring sedentary empire and the disruptive, transformative impact of a new nomadic conquest. The Sasanians subtly deepened the existing Iranian genetic layer from the west, while the Hephtalites introduced a powerful new wave of Central/East Asian DNA from the northeast, adding further complexity and regional variation to the genetic makeup of the Afghan people. The middle of the 7th century CE marked a monumental turning point in the history of Afghanistan, with the arrival of Arab armies carrying the banner of the new religion of Islam. The Arab conquest of the Sasanian Empire and their subsequent push into Central Asia initiated a process that would profoundly reshape the region's culture, religion, and, to a notable extent, its genetic landscape. The Islamic conquest of Afghanistan was not a swift, single event but a protracted and arduous struggle that lasted for centuries. The rugged terrain and the fierce resistance of local rulers and principalities meant that Arab control was often tenuous, particularly in the mountainous interior. However, in the major cities and plains of the west and south, such as Herat, Zaranj, and Bust, Arab garrisons were established, and colonies of Arab tribesmen were settled. These settlements, intended to secure the new frontiers of the Caliphate, became the primary vectors for the introduction of new genetic lineages from the Arabian Peninsula and the wider Middle East. The most direct genetic evidence of this influx is the presence of Y-chromosome haplogroup J1, particularly its p58 subclade, which is strongly associated with Semitic-speaking populations of the Middle East and is often considered a signature marker of the Arab expansion. While haplogroup J in general was already present in the region from the Neolithic period, as J2, the specific J1 lineages linked to the Arabian Peninsula were a new addition. The frequency of J1 in modern Afghanistan is not high across the board, but it is found in specific populations and lineages, often among families or groups who claim Arab descent, such as some Sayyids, who trace their lineage to the Prophet Muhammad. This pattern suggests that the Arab genetic impact was not a widespread demographic replacement but rather a process of elite diffusion, where the DNA of a small but influential group of settlers, soldiers, and religious figures was integrated into the local population over many generations. The process of conversion to Islam itself facilitated this genetic mixing. As local populations gradually adopted the new faith, the social barriers between the Arab newcomers and the indigenous Bactrian, Persian, and Hephthalite descendant peoples began to break down. Intermarriage became more common, especially between Arab men and local women, a pattern that would primarily introduce new paternal, Y-DNA lineages while integrating them into the existing maternal, mtDNA gene pool. The establishment of major Islamic centers of learning and administration in cities like Balkh and Herat also attracted scholars, merchants, and administrators from other parts of the Islamic world, including Syria, Iraq, and Persia. This created a more cosmopolitan urban environment, further promoting genetic exchange. While the primary genetic flow was from the core lands of the Caliphate into Afghanistan, the movement was not entirely one way. Afghan soldiers were highly valued and recruited into the armies of the Caliphate, serving as far away as North Africa and Spain, which represents a minor outmigration of Afghan DNA. The Arab genetic legacy is therefore subtle but significant. It did not overwhelm the pre-existing Indo-Iranian and Central Asian genetic strata, but it added a distinct new element from the southwest, directly linking the Afghan gene pool to the heartland of the Middle East. This connection is culturally reinforced by the adoption of Islam and the Arabic script, but it has a tangible biological basis as well. The presence of specific Middle Eastern genetic markers in the DNA of some Afghans today is a living testament to this pivotal period of conquest, settlement, and religious transformation. It highlights a recurring theme in Afghan genetic history: the absorption and integration of new peoples, where newcomers are incorporated into the existing population, enriching its diversity rather than replacing it. The soldiers and settlers who arrived from the Arabian deserts nearly 1,400 years ago left an indelible mark, one that contributed another unique thread to the intricate and multicolored genetic tapestry of the Afghan people. Beginning in the 10th century CE, a new and powerful wave of migration and conquest originating from the Eurasian steppe began to sweep across Central Asia and the Middle East, leaving a profound and lasting impact on the genetics and culture of Afghanistan. This was the era of the Turkic peoples, whose ascendancy marked a major demographic and linguistic shift. Unlike the earlier Indo-Iranian steppe migrants, these Turkic tribes spoke languages from a completely different family and carried a distinct genetic profile, representing a new fusion of West and East Eurasian ancestries. The first major Turkic power to dominate the region was the Ghaznavid Empire, which emerged in the late 10th century from a dynasty of Turkic slave soldiers, Mamluks, who had served the previous Persian Samanid rulers. Centered in Ghazni, in eastern Afghanistan, the Ghaznavids, under famous rulers like Mahmud of Ghazni, carved out a vast empire stretching from Persia to northern India. The Ghaznavid army was a multi-ethnic force, but its core was composed of Turkic cavalry, and their rise to power brought a significant number of Turkic tribes and soldiers into Afghanistan, who settled in the region. This was followed by the even larger-scale migrations associated with the Seljuk Turks. After defeating the Ghaznavids in the 11th century, the Seljuks established a massive empire that controlled a vast territory from Anatolia to the western frontiers of China. Their migration was not just a military conquest but a major demographic movement, as entire tribes of Oghuz Turks moved out of their Central Asian homeland in search of new pastures and opportunities. Afghanistan, situated directly on their migratory path, witnessed a substantial influx of these Turkic groups. Genetically, these Turkic peoples were a composite population. Their origins lay in the eastern steppes, and they carried a significant amount of East Asian and Siberian ancestry, evidenced by Y-DNA haplogroups like C, Q, and N, and specific mtDNA lineages. However, by the time they reached Afghanistan, they had already spent centuries interacting and mixing with the Indo-Iranian, Scythian and Sogdian peoples of Central Asia. As a result, the Turkic migrants themselves were already a blend, carrying West Eurasian haplogroups like R1a and J2 alongside their characteristic East Eurasian markers. Their arrival in Afghanistan initiated a new and extensive round of admixture. They intermarried with the local Tajik, Persian-speaking, and Pashtun populations, creating new blended communities. The genetic impact of this Turkic layer is visible today in most Afghan ethnic groups, but it is most pronounced among the Uzbeks and Turkmens of northern Afghanistan, who are direct linguistic and genetic descendants of these medieval Turkic tribes. However, even among Tajiks and Pashtun, a noticeable percentage of Turkic or Siberian-related ancestry can be detected, testifying to the widespread nature of this admixture. This genetic exchange was facilitated by the political and social structures of the time. Turkic dynasties ruled the region for centuries, and a Turkic military and political elite was a constant feature. Over time, many of these Turkic groups underwent a process of cultural and linguistic assimilation, adopting the Persian language and culture that was dominant in the urban centers. This is particularly true for groups that settled further south. This cultural assimilation, however, did not erase their genetic contribution. Instead, it allowed their DNA to be more seamlessly integrated into the non-Turkic-speaking populations. The rise of the Turks thus added a substantial and complex new genetic layer to the Afghan population. It reinforced the Central/East Asian ancestral component that had been introduced earlier by groups like the Hephthalites, but on a much larger and more widespread scale. It also created new ethno-linguistic groups, such as the Afghan Uzbeks, who retain their Turkic language and identity. The genetic signature of this era is a testament to the dynamic and often turbulent nature of the Central Asian steppe, which acted as a perpetual source of new peoples and new genetic combinations. The DNA of a typical Afghan today is a complex mosaic, and a significant part of that mosaic was pieced together during the age of the Ghaznavids and Seljuks, a time when the Turkic horsemen of the steppe became the new masters of the region and wove their own distinct genetic thread into the ever-evolving Afghan tapestry. In the early 13th century, a cataclysmic force erupted from the steppes of Mongolia that would forever alter the course of Asian and world history, leaving a deep and enduring scar on the demographic and genetic landscape of Afghanistan. The Mongol invasion, led by Genghis Khan and his successors, was an event of unparalleled brutality and scale. The campaigns of 1219 to 1221 were particularly devastating for the prosperous cities of the Khwarezmian Empire, which then ruled over Afghanistan. Cities like Balkh, Herat, and Bamiyan, which were centers of civilization and commerce, were razed to the ground, their populations massacred in enormous numbers. This violent conquest caused a massive demographic collapse, a population bottleneck that profoundly affected the region's gene pool by eliminating many existing male and female lineages. However, alongside this destruction, the Mongols also introduced a potent new genetic signature that was spread far and wide by the invading armies. The primary genetic marker associated with the Mongol expansion is a specific lineage within the Y-chromosome haplogroup C2, formerly known as C3, characterized by a unique cluster of genetic markers known as the C2M217, or more popularly, the Genghis Khan lineage. This particular paternal line is found in an astonishingly high number of men across the former Mongol Empire, from the Pacific to the Caspian Sea. It is estimated that as many as 16 million men in this vast region, or about 0.5% of the world's male population, are direct line descendants of a single man who lived approximately 1,000 years ago. While it is impossible to definitively prove this ancestor was Genghis Khan himself, the lineage's explosive spread and geographical distribution align perfectly with the timeline and extent of the Mongol conquests, strongly suggesting it belonged to him or his close male relatives. The social structure of the Mongol Empire facilitated this remarkable genetic proliferation. Genghis Khan and his sons and grandsons had numerous wives and concubines, often taken from conquered populations, and they sired a great many children. Their male descendants, who formed the new ruling aristocracy across Asia, enjoyed similar privileges, allowing this single Y-chromosome lineage to multiply and spread with incredible speed and success. In Afghanistan, the Mongol genetic legacy is particularly evident in the Hazara people of the Central Highlands. Genetic studies have shown that the Hazaras exhibit the highest frequency of the Genghis Khan lineage, outside of Mongolia itself. A significant percentage of Hazara men carry this specific C2 marker, providing strong biological evidence for the historical accounts that link their origins to the Mongol soldiers who settled in the region after the conquest. According to tradition, the Hazaras are descended from the Minghans, or thousands military units of the Mongol army that were garrisoned in the Hazarajat region. Over the centuries, these Mongol soldiers and their descendants intermarried with the local Persian-speaking populations, adopted Islam, primarily of the Shia sect, and eventually developed the distinct Persian dialect known as Hazaragi. This ethnogenesis created a unique population with a blend of East Asian Mongol paternal ancestry and West Eurasian local maternal ancestry. The Mongol genetic impact was not confined to the Hazaras, however. While less concentrated, the C2 haplogroup and other East Asian-related markers associated with the Mongols and their allied tribes, such as the Tatars and Karaits, were disseminated, albeit at lower frequencies, into other Afghan ethnic groups, including some Pashtun, Tajik, and Uzbek populations. This occurred through the gradual absorption of smaller Mongol remnant groups, and through the general mixing of populations in the chaotic aftermath of the invasions. The Mongol conquest, therefore, represents a unique and powerful example of how a small group of conquerors can have a disproportionately large and lasting genetic impact, especially on paternal lineages. It was a demographic event defined by both subtraction, the mass killing of existing populations, and addition, the widespread introduction of a new, highly successful paternal line. The shadow of Genghis Khan looms large over Afghan history, not just in the memory of destroyed cities, but in the very DNA of its people, a stark biological reminder of one of the most violent and transformative episodes in the human story. After the devastation wrought by the Mongol conquests, the 14th and 15th centuries witnessed a remarkable period of cultural and economic revival in Central Asia, known as the Timurid Renaissance. This era was named for its founder, Timur, also known as Tamerlane, a warlord of Turco-Mongol descent who sought to emulate the conquests of Genghis Khan. From his magnificent capital at Samarkand, and later from Herat under his successors, Timur forged a vast empire that once again placed Afghanistan at the center of a vibrant, interconnected world. While Timur's campaigns were often as brutal as those of his Mongol predecessors, the period of stability that followed, particularly under his son Shah Rukh and later Husayn Baikara in Herat, fostered an environment of extraordinary artistic, architectural, and scientific achievement. This cultural flourishing was mirrored by a complex process of genetic mixing, as the Timurid Empire became a nexus for peoples from across Asia. Genetically, Timur himself embodied the fusion that characterized his era. He was from the Barlas tribe, a Mongol clan that had long been settled in Transoxiana and had become thoroughly Turkified, adopting Turkic language and customs. The Timurid elite was thus a Turco-Mongol aristocracy, a blend of the two most recent waves of steppe conquerors. Their rule solidified the genetic presence of both Turkic and Mongol lineages within the region's upper classes and facilitated their further integration into the broader population. The Timurid courts of Samarkand and Herat were cosmopolitan melting pots. Timur's policy was to deport skilled artisans, artists, scholars, and craftsmen from the lands he conquered and bring them to his capital cities. chronicles describe how architects from Persia and India, weavers from Damascus, and scholars from Baghdad were forcibly relocated to enrich the heart of his empire. This policy, while ruthless, created urban centers of unparalleled diversity. These new inhabitants brought their distinct genetic profiles with them, contributing to the gene pool of cities like Herat, which became one of the most splendid cities in the world. This created a new layer of urban admixture, introducing DNA from the wider Middle East and South Asia into the Central Asian genetic landscape. The Timurid Empire also controlled and revitalized the major trade routes, ensuring a constant flow of merchants and travelers. The connections between Afghanistan, Persia, India, and the Turkic Khanates to the north were stronger than ever. This constant movement of people for trade, pilgrimage, and scholarship provided a conduit for continuous low-level gene flow that further diversified the population. The genetic legacy of this period is not about the introduction of a single dominant new haplogroup, as was the case with the Indo-Aryans or the Mongols. Instead, it is about a process of intense and complex recombination of already existing elements. The Turco-Mongol, Persian, Tajik, and Pashtun populations of the region mixed more extensively than ever before. The Timurid era can be seen as a period of genetic consolidation and synthesis, where the various layers of ancestry, Neolithic farmer, Indo-Iranian, Hellenic, Kushan, Turkic, Arab and Mongol, were stirred together more thoroughly. It was during this time that many of the modern ethnic and tribal identities in Afghanistan likely began to crystallize into forms we would recognize today. The art of the period, particularly the exquisite miniature paintings from the Herat school, visually captures this diversity, depicting individuals with a wide range of physical features, reflecting the multi-ethnic reality of the Timurid world. The legacy of the Timurids is written in the stunning blue-tiled architecture of Herat and Samarkand, but it is also written in the DNA of the people. It represents a final, major pre-modern chapter of admixture, creating a highly complex and regionally varied genetic profile. This era forged a population that was resilient, diverse, and deeply connected to all the great civilizations of the Asian continent. The genes of a person from Herat today might contain signals from Timur's Barlas tribe, a Persian artist, an Indian stonemason, and a Tajik scholar, all mixed with the deeper, ancient layers of ancestry, a testament to the city's golden age as the dazzling cultural heart of a vast and vibrant empire. The dawn of the early modern era in Afghanistan was intrinsically linked to the ambitions of one of history's most formidable dynasties, the Mughals. This period, stretching from the early 16th to the mid-18th century, did not introduce a novel, external genetic component into the Afghan population in the way previous migrations had. Instead, it acted as a crucible for intense internal demographic shifts, primarily catalyzing the expansion and consolidation of the Pashtun tribes, whose genetic origins and subsequent dispersal became a defining feature of the era. The founder of the Mughal Empire, Zahir-ud-Din Muhammad Babur, was himself a product of the region's complex genetic heritage. A direct descendant of Timur on his father's side and Genghis Khan on his mother's, Babur embodied the Turco-Mongol lineage that had dominated Central Asia for centuries. After losing his ancestral domains in Fergana, he established a new base of power in Kabul in 1504. From this Afghan stronghold, he launched his conquest of the Indian subcontinent, forever linking the political destiny of Afghanistan with that of northern India. This political reality had profound demographic consequences. The early Mughal Empire, with its capital shifting between Kabul, Agra, and Delhi, facilitated movement and gene flow between the Afghan highlands and the Gangetic plains. More significantly, Mughal rule provided the backdrop against which Pashtun tribal power grew and crystallized. Genetically, the Pashtun are a deeply rooted Central Asian population. Their dominant paternal lineage is the Y-chromosomal haplogroup R1az93, the quintessential marker of the Bronze Age Indo-Iranian migrations from the steppe, which they share at high frequencies with their Tajik neighbors. This indicates a shared origin from the same ancient wave of migration. However, their genetic profile is enriched by other significant lineages, including haplogroup G and J2, linking them to the earliest Neolithic farmers of the Near East, and haplogroup L, connecting them to the ancient populations of the Indus Valley Civilization and its periphery. This composite ancestry points to a process of ethnogenesis that occurred over millennia, blending the steppe newcomers with the region's foundational agricultural populations. During the Mughal period, these Pashtun tribes, organized into powerful confederacies, were a constant force to be reckoned with. The Mughals engaged in a continuous cycle of conflict and alliance with them, attempting to control the crucial trade and military routes that ran through Pashtun territory. This dynamic environment spurred Pashtun expansion. Tribes migrated from their mountainous heartlands, moving into more fertile valleys and expanding eastwards and southwards. This expansion was not just a military or political process but a demographic one, leading to the assimilation of other, smaller groups into the powerful Pashtun tribal structure and the spread of their genetic signature over a wider geographical area. The rise of Pashtun leaders who directly challenged Mughal authority, most notably Sher Shah Suri in the mid-16th century, who briefly drove the Mughals out of India, is a testament to their growing power. The establishment of Pashtun-led dynasties and the increasing prominence of Pashtun soldiers and administrators in the courts of both Persia and India further solidified their demographic importance. Genetically, the strong patrilineal and endogamous traditions of Pashtun tribes have created distinct genetic clusters, with evidence of significant founder effects within different tribal groups. While sharing a common ancestral pool, individual tribes can show unique frequencies of certain genetic markers, a result of centuries of relative isolation and growth from a small number of founding paternal ancestors. The Mughal era, therefore, was a critical chapter in the Pashtun story, a period that saw them transform from a collection of mountain tribes into a major regional power, culminating in the establishment of the Durrani Empire in 1747, which is often considered the foundation of the modern state of Afghanistan. Their genetic legacy, forged in antiquity but consolidated during this turbulent period, remains the largest single component of the diverse Afghan nation. For centuries, a persistent and romantic narrative has woven itself into the story of Afghan origins. The theory that the Pashtun people, the nation's largest ethnic group, are descended from the lost tribes of Israel. This belief, which gained popularity among Western writers in the 19th century and is echoed in some Pashtun oral traditions and historical texts like the 17th century Moxani Afghani, posits that Pashtun are the descendants of the 10 Israelite tribes exiled by the Neo-Assyrian Empire around 722 BCE. Proponents of the theory have pointed to superficial similarities, such as some tribal names, a supposed adherence to a code of laws reminiscent of Mosaic law, Pashtunwali, and certain physical features, as proof of this ancient Semitic connection. However, the powerful tools of modern population genetics have subjected this long-standing myth to scientific scrutiny, and the results from DNA analysis are unequivocal. The genetic evidence overwhelmingly refutes the claim of an Israelite ancestry for the Pashtun people, instead anchoring their origins firmly within the well-documented demographic history of Central and South Asia. The primary tool for investigating this claim is the analysis of the Y-chromosome, which traces direct paternal lineage. Jewish populations worldwide, while diverse, share a common ancestral pool from the ancient Levant, characterized by a specific set of Y-DNA haplogroups. The most famous of these are J1, specifically the subclade JP58, which includes the Cohen modal haplotype, and J2, specifically the J2A L556 subclade, along with certain lineages of haplogroup E. If the Pashtun were indeed descended from the lost tribes, their paternal genetic profile would be dominated by these specific Levantine markers. The reality, however, is starkly different. The single most dominant Y-DNA haplogroup among Pashtun, often found in over 50% of the male population, is R1AZ93. This lineage is the classic genetic signature of the Bronze Age Indo-Iranian migrations from the Eurasian steppe. Its geographic distribution peaks in Central Asia, Eastern Iran, Afghanistan, and northern India, precisely tracking the path of the Aryan waves, and it has almost no presence in ancient or modern Levantine populations. The foundational paternal marker of the Pashtun points not to the Middle East, but to the vast grasslands north of the Caspian and Aral seas. While haplogroups J1 and J2 are indeed found at low to moderate frequencies among Pashtun, detailed subclade analysis reveals that these are not the specific lineages associated with Jewish ancestry. Instead, the Pashtun J2 lineages are typically ancient Central Asian or Near Eastern variants linked to the 8,000-year-old expansion of Neolithic farmers, a demographic movement that affected a vast swath of Eurasia from Europe to India. The shared presence of a high-level haplogroup like J2 simply indicates a common, but far more ancient, origin from the broader Near East, long before the ethnogenesis of the Israelite people. Autosomal DNA, which provides a comprehensive overview of a person's total ancestry from all lines, delivers the final verdict. These studies consistently place Pashtun in a genetic cluster alongside their geographic neighbors, Tajiks, Kalash, and other northern South Asian and Central Asian groups. They show no specific or elevated genetic affinity with any modern Jewish population, Ashkenazi, Sephardic, Mizrahi, or with other Levantine populations like the Druze or Samaritans. The genetic distance between Pashtun and Middle Eastern groups is vast, reflecting separate evolutionary paths stretching back many millennia. Therefore, while the story of the lost tribes remains a fascinating element of cultural history and a testament to the human desire to forge epic origin narratives, it is a myth unsupported by science. The true story of Pashtun origins, as written in their DNA, is no less epic. A rich tapestry woven from the threads of ancient Neolithic farmers, city builders of the Indus Valley periphery, and most importantly, the Indo-Iranian horsemen who swept down from the steppe to shape the linguistic, cultural, and genetic destiny of a vast portion of Asia. High in the forbidding colossal landscapes of the Pamir Mountains, a region often called the roof of the world, reside some of the most genetically fascinating populations in all of Eurasia. The remote, high-altitude valleys of Afghanistan's Badakhshan province and the adjoining areas of Tajikistan, Pakistan, and China have served as human sanctuaries for millennia. This extreme geographic isolation has acted as a powerful buffer against the waves of conquest and migration that reshaped the demographics of the lowland plains, preserving ancient linguistic and genetic lineages that have been diluted or erased elsewhere. The Pamiri peoples are not a monolithic entity but a collection of distinct communities, each historically confined to a specific valley, speaking one of several archaic Eastern Iranian languages like Waki, Shugni, or Ishkashimi. This linguistic diversity itself hints at a long history of separation and independent evolution, a pattern that is mirrored with stunning clarity in their DNA. The primary forces shaping the genetics of these mountain communities are the founder effect and genetic drift. The founder effect occurs when a new population is established by a very small number of individuals, whose gene pool may differ by chance from the source population. Genetic drift describes the random fluctuations in the frequency of gene variants in a small population over time. In the isolated valleys of the Pamirs, these processes have operated with exceptional strength for thousands of years. As a result, different Pamiri groups, even those living in adjacent valleys, can exhibit remarkably distinct genetic profiles. While they share a common ancestral substrate, each valley has become a unique evolutionary experiment. For example, Y-chromosome studies have revealed that certain Pamiri populations have some of the highest recorded frequencies of specific haplogroups in the world. Many groups show an overwhelming prevalence of haplogroup R1az93, the marker of the ancient Indo-Iranian migrations. The concentration of this lineage can reach over 80% in some communities, far higher than in the more admixed Pashtun and Turkic populations of the lowlands. This suggests that the initial settlement of these valleys may have been carried out by a small number of Bronze Age pioneering families, whose paternal lineages, through drift and cultural tradition, became almost universal among their descendants. Other Pamiri groups, however, tell a different story. Some show unexpectedly high frequencies of haplogroup J2, suggesting their founding ancestors were more closely related to the Neolithic agriculturalists who moved into the mountainous regions of Central Asia. Still others have preserved haplogroup G lineages at higher rates than their neighbors. This valley-to-valley genetic variation makes the Pamir region a living laboratory for studying the effects of isolation on human populations. Crucially, the Pamiris often lack the genetic markers associated with more recent historical events. The Y-DNA haplogroups C and Q, the clear signatures of the medieval Turkic and Mongol expansions, are typically found at very low frequencies or are completely absent in many Pamiri communities. Similarly, the J1 lineages associated with the Arab conquest are largely missing. Their DNA is thus a more direct reflection of the ancient past, a genetic snapshot of Central Asia as it may have existed in the Iron Age or even the Late Bronze Age. This makes them an invaluable resource for understanding the peopling of the entire region. They can be seen as relict populations, preserving ancestral components that provide a baseline against which the more complex, multi-layered genetics of lowland Afghans can be compared. The Pamiri people, therefore, are guardians of an ancient world. Their unique languages, cultures, and DNA are inextricably linked, all products of millennia spent in one of the planet's most extreme and isolated environments. They are not merely a peripheral detail in the Afghan story, but a fundamentally important chapter, offering a clear window into the deep genetic history of the crossroads of Asia. Residing in the rugged central highlands of Afghanistan known as the Hazara, The Hazara people have long been a distinct element of the nation's ethnic mosaic, distinguished by their East Asian physical features and their adherence to Shia Islam. For centuries, their own oral traditions and the accounts of their neighbors have pointed to a dramatic origin story, that they are the descendants of the Mongol armies who stormed into the region under the command of Genghis Khan in the 13th century and subsequently settled there. This historical narrative, once a subject of speculation and debate, has now been placed on a firm scientific footing by a wealth of genetic evidence. The DNA of the Hazara people provides one of the clearest and most compelling examples of large-scale admixture and elite male dominance in the entire human story, confirming their origins in the crucible of the Mongol Empire. The most powerful piece of evidence comes from the Y-chromosome, which traces direct paternal ancestry. A remarkable number of Hazara men carry a specific Y-DNA lineage belonging to haplogroup C2, M217. This lineage is defined by a characteristic genetic signature that has been famously dubbed the Genghis Khan lineage, due to its star-like explosion from a single ancestor roughly 1,000 years ago and its geographic distribution, which perfectly matches the boundaries of the Mongol Empire. The frequency of this paternal marker among the Hazara is among the highest in the world, second only to populations within Mongolia itself. This provides an unambiguous genetic link, a direct biological paper trail, connecting a significant portion of the Hazara paternal gene pool to the Mongol conquerors of the 13th century. The story becomes even more detailed when examining autosomal DNA, which analyzes an individual's entire genetic makeup. These studies reveal that the Hazara form a distinct genetic cluster, clearly separate from other Afghan ethnic groups. Their genomes are a near-perfect admixture of two distinct ancestral sources. Approximately 50 to 60% of their ancestry is of East Asian origin, and is genetically closest to modern-day Mongol and other Northeast Asian populations. The remaining 40 to 50% is of West Eurasian origin, and is most similar to their immediate geographic neighbors, the Tajiks. This genomic evidence paints a vivid picture of their ethnogenesis. A large group of men of East Asian origin, the Mongol soldiers and administrators, systematically intermarrying with a local West Eurasian, Persian-speaking female population. This model is further confirmed by the analysis of mitochondrial DNA, mtDNA, which traces the maternal line. In stark contrast to their paternal DNA, the mtDNA of the Hazaras is overwhelmingly West Eurasian. Their maternal lineages are very similar to those of Tajiks and other neighboring groups, with haplogroups like H, U, and J being common. East Asian maternal haplogroups are present but at much lower frequencies. This classic pattern of sex-biased admixture, East Asian Y chromosomes combined with West Eurasian mtDNA, is the definitive genetic signature of a male-mediated conquest and settlement. Modern genetic dating techniques, which analyze the length of uninterrupted segments of DNA from each ancestral population, can even estimate when this mixing occurred. For the Hazara, these methods point to an admixture event that took place approximately 25 to 30 generations ago, placing their origins squarely in the 13th and 14th centuries, in perfect alignment with the historical timeline of the Mongol invasion and the subsequent Ilkhanate period. The Hazara are therefore not a genetic enigma but a living historical document. Their DNA tells a precise and powerful story of conquest, settlement, and fusion, where the descendants of steppe warriors and local agriculturalists merged to create a new and distinct people. They stand as a powerful testament to the enduring genetic shadow cast by Genghis Khan and his armies, a biological legacy etched into the very landscape of the Afghan highlands. Hidden away in the fiercely rugged and heavily forested mountain valleys of the eastern Hindu Kush lies Nuristan, a region whose people represent one of the most enigmatic and ancient branches of the Afghan family tree. Until their forcible conversion to Islam at the end of the 19th century by Emir Abdur Rahman Khan, the Nuristanis were known to the outside world as Kafirs, infidels, and practiced a unique polytheistic religion, preserving beliefs and rituals with deep Indo-European roots that had vanished elsewhere millennia ago. This remarkable cultural and religious isolation was a direct consequence of their geographic seclusion, a factor that also allowed them to preserve a unique linguistic and genetic heritage. The languages of Nuristan are as distinctive as their pre-Islamic culture. They form a third, independent branch of the Indo-Iranian language family, separate from the two major branches of Iranian, which includes Pashto and Dari, and Indo-Aryan, which includes the languages of northern India. This linguistic status suggests that the ancestors of the Nuristanis separated from the mainstream of Indo-Iranian speakers at a very early stage, likely during the initial wave of migrations into the region during the Bronze Age, around 4,000 years ago. Their language is a living fossil, preserving archaic features that shed light on the common ancestor of all Indo-Iranian tongues. This ancient and distinct identity is mirrored in their genetic profile. DNA analysis of Nuristani populations reveals them to be a unique cluster within the broader Central Asian genetic landscape. Like other major groups in Afghanistan, their primary paternal lineage is Y-chromosome haplogroup R1a, the signature of the Indo-Iranian steppe migrations. This confirms their origin as part of that Great Bronze Age expansion. However, the specific subclades of R1a found among Nuristanis, combined with their autosomal DNA, show clear signs of a population that has experienced a long period of profound isolation. They have undergone significant genetic drift, which has made them distinct from their Pashtun and Turkic neighbors who inhabit the lower-lying valleys. Their genomes show a near-total absence of the genetic markers associated with later historical events. The Arab, Turkic, and Mongol conquests, which left clear genetic footprints on other Afghan populations, appear to have bypassed Nuristan entirely. Their DNA is a pristine window into an earlier era, a genetic snapshot of the Eastern Hindu Kush from the Iron Age. This has led to the compelling hypothesis that the Nuristanis are the most direct descendants of the original Vedic Aryans, the people who composed the Rig Veda, the oldest sacred text of Hinduism. Their ancient polytheistic religion, with its pantheon of gods, fire rituals, and complex cosmology, shared numerous striking parallels with the early Vedic religion described in the texts. It is plausible that while some groups of these early Indo-Iranians migrated further south into the Indian subcontinent, evolving into the Vedic civilization of India, the ancestors of the Nuristanis remained in their high mountain redoubt, preserving their original language and faith in a state of arrested development for over 3 millennia. Their genetic profile, largely unburdened by subsequent layers of admixture, supports this narrative of antiquity and continuity. The Nuristanis, therefore, stand as guardians of a lost world. They are a crucial piece of the puzzle for understanding the deep history of the Indo-Iranian peoples. Their unique language, their pre-Islamic traditions, and their distinctive genetic signature combine to tell a story of remarkable resilience, a testament to the power of mountains to shelter and preserve the ancient heritage of humankind. They are not merely an isolated curiosity but a living link to the very dawn of the Indo-Iranian story in the heart of Asia. In the vast, arid landscapes of southern Afghanistan, where the country bleeds into the deserts and rugged hills of Iran and Pakistan, live two distinct peoples whose genetics tell a fascinating story of migration, language shift, and deep history: the Baloch and the Brahwi. The Baloch, speaking a northwestern Iranian language, are the product of a relatively recent and well-documented migration. Their oral traditions and linguistic ties point to an ancestral homeland far to the west, near the Caspian Sea. Sometime in the early medieval period, likely between the 6th and 10th centuries CE, their ancestors began a slow, multi-generational migration eastward, eventually settling the vast, sparsely populated region that now bears their name, Balochistan. Genetic analysis provides striking confirmation of this narrative. The paternal lineages of the Baloch people show a strong connection to the western Iranian plateau and the Caucasus. While they possess the ubiquitous Central Asian R1a haplogroup, they also carry significant frequencies of Y-DNA haplogroups J2 and G, lineages that are much more common in western Iran and Anatolia. Their autosomal DNA profile clusters them closely with other Western Iranian populations, clearly distinguishing them from their immediate geographic neighbors, the Pashtun to the north and the Sindhis to the east. The Baloch are therefore a clear case study of how a population's genetics directly reflect its migratory history, carrying a Western genetic signature into the heart of the Eastern Iranian world. Interspersed among the Baloch, often living in the same communities, are the Brahwi, who present one of the most intriguing linguistic and genetic puzzles in all of Asia. While culturally and physically similar to the Baloch, they speak Brahwi, a language that belongs to the Dravidian family. This is extraordinary because all other Dravidian languages, such as Tamil, Telugu, and Kannada, are spoken thousands of kilometers away in southern and central India. The Brahwi are a linguistic island, a remnant of a language family now geographically isolated by a vast sea of Indo-Iranian languages. This has led to two main hypotheses. Either the Brahwi are a relict population, the last northern survivors of a Dravidian language family that was once more widespread, perhaps even linked to the Indus Valley civilization, or their ancestors migrated from South India to Balochistan at some point in the distant past. Genetics was expected to solve this puzzle. The prediction was that if the Brahwi were a relict of an ancient northern Dravidian group, or migrants from the south, their DNA should show a strong and distinct South Asian/Dravidian ancestral component, setting them apart from the Baloch. The results, however, were astonishing. Genetic studies have demonstrated that the Brahwi people are, for the most part, genetically indistinguishable from their Baloch neighbors. Their Y-chromosome haplogroups are nearly identical in type and frequency to the Baloch, dominated by Iranian and West Eurasian lineages like R1a, J2, and G. Their autosomal DNA shows that they are overwhelmingly of the same West Eurasian/Iranian ancestry as the Baloch and possess only a very minor South Asian component, no more than would be expected from routine local gene flow. The deep genetic connection to Dravidian-speaking populations of India is missing. This discrepancy between language and genetics points to a classic case of language replacement through elite dominance. The most plausible scenario is that the ancestors of the modern Brahwi were a local population genetically identical to the ancestors of the Baloch. At some point in their history, they came under the influence of a small, politically dominant but now vanished group of Dravidian speakers. This elite group imposed its language on the much larger local population, a phenomenon seen elsewhere in the world. Over time, the original Dravidian-speaking elite became completely absorbed through intermarriage into the larger local gene pool, disappearing genetically but leaving their language behind as a permanent legacy. The Baloch and Brahui, therefore, offer two contrasting but complementary lessons in population genetics. The Baloch show how genes and language can travel together in a clear migration. The Brahui, conversely, provide a powerful reminder that language and deep genetic ancestry are not always linked, and that a group's modern tongue may be a cultural inheritance that tells a different story from the one written in their DNA. Beyond the dominant Pashtun population, the rich ethnic fabric of Afghanistan is primarily woven from two other major groups, the Tajiks and the Uzbeks, whose distinct histories and genetics encapsulate the enduring duality of the region's heritage, its deep-seated Iranian foundations and the transformative impact of the Central Asian steppe. The Tajiks, the second-largest ethnic group, are speakers of Dari, the Afghan dialect of the Persian language. They are widely considered to be the most direct modern descendants of the ancient Eastern Iranian peoples who have inhabited the region for millennia, the Bactrians, Sogdians, and others who founded the first agricultural civilizations north of the Hindu Kush. Their identity is tied not to a tribal confederacy, but to a shared language, culture, and a settled, often urban or agricultural way of life. The Tajik genetic profile is a quintessential reflection of this deep history. Their primary paternal lineage is Y-DNA haplogroup R1AZ93, the indelible marker of the Bronze Age Indo-Iranian migrations, which they share with Pashtun. This confirms their shared origin from the same foundational wave of steppe pastoralists. This is built upon an even older genetic substrate of Neolithic farmer lineages, particularly J2 and G, which are found at significant frequencies and connect them to the very first agriculturalists who settled the fertile river valleys of Bactria. Autosomal DNA analysis places the Tajiks at the very heart of the Central Asian genetic cluster, representing a baseline population for the region. However, the term Tajik encompasses significant regional diversity. A Tajik from the city of Herat in the west, a historic center of Persian culture, may show a greater genetic affinity with populations from the Iranian plateau, a legacy of centuries of interaction and Sasanian influence. In contrast, a Tajik from the northern provinces bordering the Amu Darya may carry a higher proportion of Turkic and Mongol admixture, a result of centuries of coexistence and intermarriage with their Uzbek neighbors. Concentrated primarily in the northern provinces of Afghanistan, the Uzbeks are a Turkic-speaking people whose ethnogenesis is a direct result of the medieval migrations from the Eurasian steppe. Their identity is tied to the successive waves of Turkic tribes, such as the Karluks, Ghaznavids, and Seljuks, and later Turco-Mongol confederations like the Shaybanids, who came to dominate the region from the 10th century onwards. The Uzbek genetic profile is a clear and compelling illustration of this history of admixture. They represent a classic hybrid population, a fusion of West and East Eurasian ancestries. Their Y-DNA is a diverse mosaic, containing the Indo-Iranian R1A and Neolithic J2 lineages of the pre-existing Tajik-like population, alongside the characteristic East Asian and Siberian paternal markers of the Turkic and Mongol steppe nomads, such as haplogroups C, Q, and N. Their autosomal DNA confirms this dual ancestry, placing them on a genetic line stretching between the Tajiks on the one hand and East Asian populations like Mongols on the other. Comparing the two groups reveals the complex story of Afghanistan's medieval and early modern history. The Tajiks represent the continuity of the ancient Iranian-speaking world, a population that absorbed later influences but retained its core genetic and linguistic identity. The Uzbeks, in contrast, represent a process of transformation, where new Turkic-speaking migrants settled, intermarried with, and partially assimilated the local Iranian population, creating a new, blended Turco-Persian identity. In the north of Afghanistan, the genetic and cultural lines between Tajik and Uzbek can often be blurred. Centuries of shared history in cities like Mazar-i-Sharif and Kunduz have led to extensive intermarriage and widespread bilingualism, creating a genetic and cultural continuum rather than a sharp ethnic divide. Together, these two peoples beautifully illustrate the dynamic history of Central Asia, a story of an ancient, settled, Iranian-speaking civilization in constant interaction with the recurring waves of nomadic, Turkic-speaking peoples from the vast northern steppes. For over 1,500 years, the vast network of trade routes collectively known as the Silk Road formed the connective tissue of the ancient world, a vibrant artery pumping goods, ideas, and religions between the great civilizations of Rome and China. Lying at the geographic heart of this network, the territories of modern Afghanistan were not merely a transit corridor but the central marketplace, the essential crossroads where east, west, north, and south converged. While histories often focus on the flow of silk, spices, and philosophies, this constant movement of people also made the Silk Road a genetic superhighway, facilitating a continuous, low-level, and long-distance gene flow that subtly yet perpetually enriched the DNA of the Afghan people. This genetic exchange was not the product of mass migrations or conquering armies, but of the cumulative effect of countless individual journeys undertaken over centuries. The caravans that plied these routes were mobile, multi-ethnic communities. A single caravan might include a Sogdian merchant from Samarkand, his Indian financiers, Chinese silk buyers, Turkic camel drivers, and Persian guards. The bustling oasis cities of Afghanistan, such as Balkh, hailed as the mother of cities, and later Herat and Kabul, became cosmopolitan melting pots where these travelers would reside for extended periods, conduct business, establish communities, and sometimes start families. This process allowed for the introduction of DNA from the farthest reaches of the known world into the central Afghan gene pool. From the west, Roman and later Byzantine merchants seeking silk and spices, along with artisans and diplomats, would have left a faint but discernible trail of Mediterranean and Levantine lineages. The eastward spread of religions like Nestorian Christianity and Manichaeism, carried by missionaries from Syria and Mesopotamia, would have also contributed Middle Eastern DNA. Evidence of these communities can be found in archaeological records, and their genetic legacy, however small, would have been absorbed into the urban populations. From the east, the flow was equally significant. Han Chinese envoys, princesses dispatched for diplomatic marriages with Central Asian rulers, and merchants seeking the famed heavenly horses of Fergana traveled westward, introducing East Asian genetic markers. The most profound movement, however, was religious. The transmission of Buddhism from its heartland in India, through Afghanistan and into China, created a two-way pilgrimage route that was active for nearly 1,000 years. Chinese monks like Faxian and Xuanzang famously journeyed to Afghanistan to study at great monastic centers like Bamiyan, while Afghan and Central Asian monks traveled east to become influential missionaries in China. This sustained religious and intellectual exchange inevitably resulted in a degree of genetic exchange. The primary agents of commerce, and therefore gene flow, along much of the Silk Road were the Iranian-speaking Sogdians. For centuries, these master traders established a network of colonies from the Black Sea to the borders of China, and their constant movement would have had a homogenizing effect, spreading specific Central Asian genetic variants across a vast territory and reinforcing the shared Indo-Iranian ancestry of the region. The ultimate genetic legacy of the Silk Road is not seen in the creation of new, distinct ethnic groups, but in the increased genetic diversity and cosmopolitanism of the populations that lived along its path, particularly in urban centers. It ensured that the Afghan gene pool was never completely isolated, constantly receiving a trickle of new alleles from distant lands. This process stands in contrast to the demographic shock of a major invasion. It was a slow, continuous infusion that added layers of complexity and subtle variation. The DNA of an Afghan citizen today is therefore not just a record of major migrations, but also a quiet testament to this ancient era of globalization, containing faint echoes of the myriad travelers who journeyed through their land, making the Afghan people a true genetic microcosm of the Eurasian continent. While the grand narratives of conquest and migration that shaped Afghanistan are often dominated by the stories of men, warriors, kings, and nomads, a complete understanding of the nation's genetic history requires looking through a different lens, one that follows the female line. This is the story told by mitochondrial DNA, mtDNA, a unique portion of the genome passed down exclusively from mother to all her children. Because it traces a direct, unbroken maternal lineage, mtDNA can reveal patterns of female migration, social structure, and population continuity that are often invisible when looking at the male-centric Y-chromosome alone. The overall picture painted by the mtDNA of the Afghan people is one of profound antiquity and remarkable stability. The overwhelming majority of maternal lineages in Afghanistan, across all major ethnic groups, belong to the West Eurasian haplogroups. Lineages such as H, U, T, J, and V, which are common throughout Europe, the Near East, and Central Asia, form the bedrock of the Afghan maternal gene pool. This indicates that the foundational female population of Afghanistan descends from the same broad ancestral groups as the foundational male population. The pre-agricultural Paleolithic hunter-gatherers of West Eurasia, and the subsequent wave of Neolithic farmers who spread out from the Near East starting around 9,000 years ago. Many of these maternal lineages have incredibly deep roots in the region. Certain subclades of haplogroup U, for instance, particularly U2, U4, and U7, are ancient in Central Asia, with a time depth stretching back tens of thousands of years. This suggests that the women who carried these genes were indigenous to the broader region long before the arrival of agriculture or the Indo-Iranian migrations. When later groups of male farmers or steppe pastoralists moved in, the genetic evidence points to a recurring pattern of admixture with these local women, who were already deeply rooted in the land. This story of deep local continuity is complemented by significant contributions from neighboring regions. There is a substantial and important minority of maternal lineages that belong to South Asian haplogroups, primarily diverse subclades of the M macrohaplogroup. This genetic link to the Indian subcontinent is a clear legacy of the ancient Indus Valley civilization's influence, and the millennia of continuous cultural and economic interaction across the Hindu Kush. Interestingly, this South Asian maternal signal is often stronger and more diverse than the corresponding paternal signal, suggesting a historical pattern where women from the subcontinent more frequently married into Afghan communities than men. In sharp contrast, East Asian maternal lineages, such as a BDG, are present but at significantly lower frequencies than East Asian paternal lineages, particularly in groups like the Hazaras. This creates a striking asymmetry and provides powerful independent confirmation of a sex-biased admixture pattern during the Turkic and Mongol conquests. These events were primarily male-driven military expansions. The incoming male warriors contributed their East Asian Y-chromosomes to the gene pool at very high rates, while the maternal gene pool remained predominantly local and West Eurasian, as the conquerors took wives from the resident population. The matrilineal saga of Afghanistan is therefore a story of deep roots and resilience, while the paternal history is one of dramatic shifts, where the Y-chromosomes of conquering elites often replaced or overwhelmed previous lineages. The maternal history shows much greater continuity. The women of Afghanistan, genetically speaking, represent the stable foundation upon which the waves of male-mediated migration were overlaid. Their mitochondrial DNA is a testament to the enduring presence of the region's most ancient peoples, a continuous genetic thread running from the Ice Age to the present day. The paternal history of Afghanistan, etched into the DNA of the Y-chromosome, is a dramatic and stratified chronicle of the successive waves of migration and conquest that have defined the region as the crossroads of Asia. Following the journeys of the major paternal haplogroups is akin to tracing a geological survey of Afghan history, where each layer represents a distinct demographic event that contributed to the formation of the modern population. This is a story of profound change, where the genetic landscape was repeatedly and fundamentally reshaped by the arrival of powerful new groups of men. The deepest, foundational paternal layer belongs to the first agriculturalists and the pre-existing peoples they encountered. Haplogroups G and J2 are the classic signatures of the Neolithic revolution, carried by the farmers who migrated from the Fertile Crescent around 9,000 years ago, bringing with them the transformative technologies of cultivation and animal husbandry. They established the first settled communities in the fertile valleys of the Hindu Kush. Alongside them were haplogroups like L and R2, ancient lineages with strong connections to the greater Indus Valley region, representing the genetic legacy of the sophisticated Bronze Age civilizations to the south and their periphery in southern Afghanistan. Together, these haplogroups form the agricultural and early urban substrate upon which all subsequent layers were built. The single most transformative event in Afghan paternal history was the arrival of the charioteers from the steppe. Beginning around 4,000 years ago, the speakers of Indo-Iranian languages, associated with the Andronovo archaeological culture, swept down from the grasslands of modern-day Kazakhstan and Russia. They brought with them a specific Y-chromosome lineage, R1AZ93, which, due to a combination of technological superiority and demographic success, became the dominant paternal line across the entire region. Today, it remains the most common haplogroup among Afghanistan's two largest ethnic groups, the Pashtun and the Tajiks, standing as an undeniable testament to this massive Bronze Age demographic replacement that forever defined the region's linguistic and paternal identity. Subsequent conquests left their own, more subtle, but still detectable marks. The march of Alexander the Great's armies and the establishment of the Greco-Bactrian kingdom in the 4th century BCE introduced a faint echo of European lineages, such as specific subclades of E1b1b and R1b. Centuries later, The Arab conquest in the 7th century CE brought the banner of Islam and a distinct Semitic inscription in the form of haplogroup J1, particularly lineages with a clear origin in the Arabian Peninsula, found today among some families who claim Arab descent. The medieval period was defined by new, massive waves of conquest from the eastern steppes. The rise of Turkic empires like the Ghaznavids and Seljuks, followed by the cataclysmic Mongol invasion, introduced a suite of East Asian paternal haplogroups, primarily C, Q, and N. The most famous of these, the Genghis Khan lineage within haplogroup C2, provides a stark and powerful genetic timestamp for the Mongol conquest, reaching its highest frequencies in the Hazara people, a direct biological legacy of the soldiers who settled the Central Highlands. In synthesizing this paternal story, a clear pattern emerges. The Y-chromosomal landscape of Afghanistan is a history of dominant, often conquering, male groups imposing their genetic signature on the population. Unlike the more stable and continuous maternal history, the paternal narrative is one of disruption and layering. From the first farmers to the Mongol horsemen, each major historical epoch is associated with a specific set of paternal journeys. The modern Afghan man is a living mosaic. His Y chromosome a passport stamped with the genetic visas of the many different peoples who have journeyed through and ruled this pivotal land.
The genetic saga reveals that Afghan identity is a mosaic created from millennia of mixing between farmers, nomads, conquerors, and traders. This rich and complex heritage is a testament to the nation's history as a true crossroads of the world. What part of this genetic journey surprised you the most? Please share your thoughts and suggestions for improvement in the comments below.